The Pirate. The Pirate is a large pendulum. This ride counts as one of the 2 circular motion rides that you should do at the park. Ideally, energy is always conserved. But is it on the Pirate? Does the potential energy at the top of the swing equal the kinetic energy at the bottom? This is what you want to find in this lab activity. Why isn't this an ideal situation? Make a prediction of what you think and then use the engineering specifications provided to calculate the potential energy. You can do this calculation before you go to the park. The kinetic energy will be calculated at the park in 2 ways. You will need both a stopwatch and the vertical accelerometer. First, you can use a stopwatch to find the time for the boat to pass through the bottom of the swing. You know the length of the boat, so the velocity is the length of the boat divided by the time it takes for the boat to pass the lowest point. Focus on a point at the very bottom of the ride. Wait until you are sure the ride is at full speed, and start timing as soon as the tip of the pirate ship gets to this point. Stop timing as soon as the back of the pirate ship reaches this point. Repeat this measurement at least 5 times and take the average. If your data is inconsistent, take even more measurements. You need to be very accurate with your calculation. This time is all you need to calculate the kinetic energy at the bottom of the swing. Kinetic energy is 1/2 times mass times velocity squared. Next, you can calculate the kinetic energy if you know the maximum acceleration at the bottom of the ride. You will need to ride the Pirate. Use the vertical accelerometer and hold it perpendicular to the lap bar. Watch it throughout the ride and note the maximum number it reaches at the lowest point of the ride. Then convert the measurement in Gs into meters per second squared. You will then use this number to calculate the centripetal acceleration on the ride. To do this, you need to subtract 1 from the maximum acceleration in Gs that you found with the accelerometer. Convert this to meters per second squared and use the equation for centripetal acceleration to determine the velocity. Remember that centripetal acceleration is equal to velocity squared divided by the radius. The radius is in the engineering specifications. Once you know the velocity, you can calculate the kinetic energy. While you are on the ride, you should also use the vertical accelerometer to answer the second question. You need to know what is the acceleration at the highest point of the ride. Record this measurement at the same time you are riding to get your measurement from the previous question. Finally, you have to graph speed versus time for at least 1 complete cycle. A cycle is from the highest point to the other side and back again. Think about the relationship between potential and kinetic energy. Then, consider the relationship between kinetic energy and speed. Good luck!